Well, I'm going to talk about BabelNet, which is the core of this research from the ERC starting grant, but also Babelfy, which is basically which constitutes the second part of this project, and also going to talk a bit more about what comes next. So this is all in the context, I try to frame this in the context of electronic lexicography, but obviously this goes beyond that because it's more from the field of natural language processing. So, well, all this work would have been impossible without all these people. Tiziano Flati, Daniele Vannello, Alessandro Raganato, Andrea Moro, Simone Ponzetto, Taher Pineva, Francesco Cecconi, Federico Scozzafava, Ignacio Jacobacci, and José Camacho Collados.
Are you Italians?
No, not all Italian, and now relax. Okay. Okay, so the thing is, I've been interested in how to encode knowledge in computers for years, for many years. And the thing is, can we expect computers to know, or can we just use statistical techniques? Like we don't care about encoding knowledge in a structured way. I mean, this is an important question in my opinion, and I've been interested in this for a long time. And so when you try state-of-the-art machine translation, sometimes you're puzzled by the output you get. Like here, this is a sentence from Wikipedia. These are movies in which the music genre, e.g. rock, is an important element, but not necessarily central to the plot. And it's clear what we're talking about, but what we get in Spanish is roca, as a translation of rock. So roca apparently is, the geological sense of rock is very important for movies, but obviously there's so much lexical context here that tells us it's not the case. So let's give it another chance. Because we're using statistics here, maybe rock in the sense of geological rock is predominant. So what if we translate, we can look at how this vast slug of molten underground rock was injected, but unfortunately when you translate this, you get underground. It's a danger here that gives you vaste bouchon de rock underground fondu a été injecté. In Italian the same, possiamo guardare come è stato iniettato questo vasto slug, which doesn't exist in Italian, del rock underground fusa, which is actually wrong also in gender. So unfortunately, and there are many examples, and now that I'm working with translations of prototypical examples from dictionary entries, you get a lot of errors of this kind, a lot. So it's, in a sense, it's, you know, we want to see what happens with computers, because when we talk to our dogs, right, we say, okay, Ginger, I had it, you stay out of the garbage, understand Ginger or else. And unfortunately, the dog understands blah, 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 Ginger, blah, 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 Ginger, blah, 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 which, however, is already 12% accuracy. So we want to do better than this. We want our computer to understand better than our dog. Well, this is the main objective of this 5-year ERC starting grant on multilingual words and disambiguation called BabelJedi, and you'll see later why. But for the moment, it's the acronym of Multilingual Joint Words and Disambiguation. And the first part of this project is about integrating knowledge. So creating this huge resource called BabelNet that tries to bring together a lot of different resources. You know, there are many openly available resources around, like WordNet, which is a fantastic computational lexicon of English, structured, we'll see later, with synsets and relations between synsets. We have Wikipedia, everybody's using Wikipedia. You have Wiktionary, which is also a very rich resource. Actually, there's a separate Wiktionary for each and every language, and each of these projects is multilingual in its own. It's a crazy N-square project in which each different language has its own multilingual resource, but very rich in terms of content with etymology, pronunciation, and so on. Then you have Omega Wiki, which is a medium-sized collaboratively created multilingual dictionary. So each entry is already multilingual by design, with definitions in different languages and lexicalizations in different languages and so on. So the key objective, the first key objective of this project was to create knowledge for all languages. So trying to move from a scenario in which you have plenty of resources of different heterogeneous coverage size and so on, and move to a unified resource, BabelNet, which integrates all of this. And actually, it all started with merging WordNet with Wikipedia. Well, WordNet, we all know, is a computational lexicon of English. It provides lexicographic entries, while Wikipedia provides encyclopedic knowledge. So you have a lot of named entities encoded in Wikipedia. And not only that, you also have a lot of specialized concepts, like much domain terminology is there. Not all of it, of course, but you have a lot of technical terms. In WordNet, you have a lot of concepts. And the interesting thing is that there's a quite big intersection between these two resources. There are many concepts and some named entities which are available in both resources. And so if we could find out what entries in the two resources are actually the same, we could merge the two resources. And so find out that this, a given entry of balloon in Wikipedia is about the same concept as a given synset in WordNet about that concept. And so, well, why merging these two resources? In a sense, it's quite obvious, because WordNet is a dictionary. It's more than a dictionary. It also provides a full-fledged taxonomy. It's structured, as I said, with synsets and relations between them, while Wikipedia provides multilinguality and is continuously updated. So merging these two resources allows us to get the best from both worlds. And WordNet, well, WordNet, as I said, can be viewed as a graph. So you can, each node in the graph is a synset in which represents a concept. So all the various lexicalizations in the synset are used to denote that concept. And the relations between synsets are, well, quite general, but important. It's fundamental relations like hypernymy, ise, meronymy has part, and so on. While Wikipedia actually is also a graph, because each page is a node in the graph, and the various hyperlinks in the page are the edges, the relations which connect a given page to another page. So this is also a graph in which concepts or named entities are the Wikipedia pages, and the relations come from the hyperlinks. And so we developed a number of alternative approaches for merging entries from different resources. This is just one of them, and I will not go into details, but just to give an idea, what we do is we take the graph of either WordNet or Wikipedia and focus on a given concept, and we want to identify from this huge graph what are the most relevant the most semantically relevant concepts for this concept. And so we apply personalized PageRank and also more sophisticated algorithms to obtain a semantic profile, a semantic signature. In a sense, it's a vector, it's a distribution, it's a probability distribution over all the concepts and named entities in the graph that tells us how semantically relevant each of these is for the target concept. And so we know that the larger these spots here, and the more semantically relevant they are for the given concept. And we do this for each and every node, each and every concept in the network. And so now we have a vector. Now we can compare different vectors from different resources. And so the thing is, when we compare, we have to decide whether they are semantically similar, whether they are similar enough to be merged or not. And so if they are similar enough, we merge the corresponding two concepts. And obviously, the two concepts have to be lexicalized the same. But you know very well that this term could be ambiguous. And so we need to see whether this sense of a given term is the same as this sense of the same term in the other resource. So for example, if we take one sense of plant in WordNet and another sense of plant from Wiktionary, we have to see, to compare their semantic representations and decide whether they are to be merged. If not, we move to the next one and see if we can find one which is whose similarity with the other sense is about a threshold. As a result of this, we are able to identify those entries from many different resources which talk about the same concept. And so the plant sensing dictionary, the plant sensing WordNet, and so on. And we merge all of these and get all the information from these resources, and we unify all this information into a single entry in BabelNet. And so, as a result of this, we collect all the lexicalizations in different languages, multiple definitions in different languages, translations, images from each of the merged resources. So as a result, we get a labeled directed graph in which the nodes in the network, the vertices, are what we call Babel synsets. So it's like in WordNet, we have synsets, but they are multilingual. So the various lexicalizations in different languages obtained from the various resources are integrated into a single synset. And the relations come from the different resources. So we have hypernymy, meronymy, instance of, we have unspecified relatedness relations from Wikipedia, but I'll tell you later what we are doing about this to label these relations which come from Wikipedia, and so on. So as a result of all this merging procedure, BabelNet is the integration of all these resources. And what are these resources? Well, not only WordNet and Wikipedia, but also we're integrating the Open Multilingual WordNet collection, which is a collection of open WordNets, Wikidata, which is the largest collaborative knowledge base, Wiktionary, as I said, the largest collaborative dictionary, Omega Wiki, and high-quality automatic sense-based translations. So all of this is integrated into BabelNet. And so basically, this is the result. But we still keep the link back to the original resources. So you don't lose that information. You can always go back to that. And so why do we need BabelNet? Well, first of all, and that was the main reason for this project, is to get multilinguality. So the same concept is now expressed in tens of languages. Like, for example, Allen Range, hex key, you have multiple definitions. What you want is to see how to translate this into as many languages as possible. So you want all these translations sorted by relevance. And so, for example, in Italian, chiave brugola, clé à lin, and so on. So all this information comes from the integration of the various resources. And these are only some of the languages which are integrated. And now with the interface I'll show you in a minute, you can also compare the definitions and the translations across languages for the same entry, the same concept. So for example, Allen Range, I don't know how to read this, sorry, Brugola, and so on. So, and you can just select the languages you're interested in and compare the definitions, compare the terms, and so on. And at the moment, BabelNet covers 271 languages and contains 14 million entries. 6.4 million concepts and 7.4 million named entities. So it's a lot of concepts, many more than in WordNet, many more than in Wiktionary because of this integration of Wikipedia and all the other resources. More than 100 million word senses, and interestingly, 11 million images associated with synsets. So now you have a lot of pictures for many entries, millions of entries, so that you can use to depict concepts visually, which is something new for a dictionary. And you have 40 million textual definitions. The other interesting idea is that thanks to this integration, you have concepts and named entities together. So now you have a network of lexicographic entries and encyclopedic entries linked to each other. So you know that, I don't know, Drive is connected to Porsche or Ferrari Testarossa or whatever, so you connect named entities with senses of verbs or common nouns and so on. And also it puts forward an idea of dictionary of the future because it provides much more structure than a normal dictionary does. So it's a semantic network with labeled relations, pictures, multilingual synsets. You can view the translations across languages at once. You have multiple definitions and so on. And also it provides a full-fledged taxonomy. So most of the synsets in BabelNet, thanks to a separate project which has now been integrated into BabelNet called the Wikipedia by Taxonomy, now we have not only the taxonomical information from WordNet, but also a fully fledged Wikipedia taxonomy thanks to which we can say that Hermonzu castle is a castle, that Hermonzu is a civil parish and it's also a village, that BabelNet is a semantic network and it's also an encyclopedic dictionary, that Ferrari Testarossa is a sports car, so very specialized information. And each of these are concepts. So when I say is a, I mean two different entries, two senses of these words are connected. For example, this is an excerpt of the taxonomy for Ferrari Testarossa, which is a sports car, which is a car, and this is the category side of Wikipedia, so you know that the Ferrari Testarossa is categorized as Ferrari vehicles, as a rear mid-engine vehicle, coupe, and so on, and all this is taxonomized. You have easy access, so you have Java and HTTP RESTful API, and you also have a Sparkle endpoint, thanks to which you can access 2 billion triples. So in a sense, this is, in the linguistic sense, it is the core of the linguistic linked open data cloud. So it's in the center. As was also said yesterday, more and more resources are linking to BabelNet, or BabelNet is linking to these resources. So hopefully this will be more and more the case over time. Now, as a user, what can I do with BabelNet? Well, you can search and translate. So you can just, I don't know, type plane and say, give me the meanings in English of plane, but also, if you want, optionally, you can say, while showing the meanings of in English, please give me beside the translations into these languages I'm going to select. And as a result, what you get is a disambiguation page in which you have the various meanings of plane in English with definitions and the translations of these meanings into the selected languages. And you can do this for up to, I don't know if there's a limit, honestly, but potentially up to 271 languages. And you have pictures beside each meaning, so at least it gives us an idea of what we're talking about. So even if I don't know English and I cannot read these definitions, I have pictures to understand what we're talking about. And you can also explore the network. So you can say, once I'm looking at a given entry, I can explore the network. And I think I'll show you a demo of this. Okay. So you just go to babelnet.org or type BabelNet on Google. Then, I don't know, we try something. I'll try calcio in Italian. You see there are many other terms starting with calcio, which are probably different variants of the chemical element. I start from Italian and translate into, I don't know, here you have some frequent languages, but you can select to any of the 270 languages. Let's say I want to try, I want to translate into English and French, well, let's say German and Hebrew, and then translate. And what I get is, if the Wi-Fi works, yes. So I get various meanings. Well, there's not much space on the screen because usually this is shown on the right. But I have one meaning of culture in terms of football, translated as soccer, or I don't know how to read this, sorry. Culture as the chemical element, and you have the translation, and the culture as a kick, culture in the gun stock meaning. So, and you have named entities, like this is a town in Italy, and wrestling meaning. So, and you have a lot of pictures, so it's very informative. And you also have some information from automatic translation, which is put below because we're not totally comfortable with automatically translated meanings. Then I select one of these, let's say this one, and now I can view the entry, the multilingual entry for this term. And so I see on the left, if I just have one sense, one language, I just view the monolingual entry. But if I select the languages I'm interested in, I can view them at once and see, well, sorry, this is English. And see the definitions, and if they are available, you can also see examples, and so you can have more definitions from the various resources we are integrating. You have easy information, you have pictures, a lot of pictures for many of these. You have all the translations at once, and you have sources, so you can see where this information comes from WordNet, Wikipedia, Wikipedia redirections, Omega Wiki, Wiktionary, and so on. And now, let's say I want to explore this network. So I click this Explore Network button, and what I get is a different view of the concept, which should allow me to explore the network. Maybe it's a bit slow, yeah. So, well, this is in Italian because I selected the Italian sense of calcio, but if I selected it in English, I can get it in any language I'm interested in. So you see you have ball, you have, I don't know, a league, you have autogol, which is something you don't want to do. You have player. So you select this and you can explore the network. So this is a new way of exploring, knowledge. Like you start from a given entry, you move to a related entry, and then you move on. And so we're also working on this because we can go beyond this. And I mean, this is just a starting point. I think we can do a lot from this. Okay, so I'll go back to the presentation. Okay. So now, the other thing is that as an annotator, you might be interested in annotating with BabelNet, because once you annotate with BabelNet, you get, thanks to this integration of all these resources, you're also implicitly annotated with all these resources: WordNet, Wikipedia, Omega Wiki, Open Multilingual WordNet, Wikidata, Wiktionary, and so on. So it's like one of those all-in-one shampoos, 7-in-1, that when you do one thing, you're actually doing 7 at the same time. So the thing is that one does not simply use BabelNet as a multilingual dictionary, and actually that was, my final objective was actually to address ambiguity, to address lexical ambiguity. And this is the second part of the project called Babelfy. And the thing is that when you look at a word in context, well, context matters. Like you have a baby crying and shouting, and the poor parents are there, and then the same guy shouting in a concert, everybody's happy, and so on. So it's exactly the same thing, but context matters. So this word that occurs in context, the context tells us a lot about this word. And so the thing is that, unfortunately, when I keep trying this statistical machine translation, these statistical machine translation systems, I find out weird things, like that computers can be hungry. For example, I take the mouse ate the cheese sentence, which is quite simple, and unfortunately in Italian you have multiple meanings for mouse. Well, in English you have multiple meanings for mouse, and in Italian you get different translations, like topo for mouse, but for computer mouse you just keep the mouse, the English mouse word. And so when you translate into Italian, you would expect something like this, but actually you get this: il mouse ha mangiato il formaggio, which is not really what you would like to. So, the statistical machine, state-of-the-art statistical machine translation system doesn't understand this, even if there are only 3 content words here, right? So more seriously, the problem is we want to address lexical ambiguity automatically, or at least semi-automatically. For example, take this sentence: Thomas and Mario played the strikers in Munich. Ideally, I would like a system to output this, to tell me who's Thomas, who is Mario, in what sense play is used, participate in games, striker as a forward on a soccer team, and Munich as the team and not the city. Actually, this involves 2 different tasks. One is entity linking, which is the task of discovering mentions of entities in a text automatically and linking them to a knowledge base. Word sense disambiguation is the second task, which is the task of computationally determining the meaning of a word in context by assigning it to a sense in a given inventory. And so, for example, here, when we consider our sentence and striker as the target word, we want our word sense disambiguation system to use knowledge or supervision to output the right meaning for this word in context. But actually, the entity linking task is very similar. I want to take Thomas as a mention in context and use knowledge to output the right meaning for Thomas. So actually, these 2 tasks are very similar, but there are 2 communities doing this, performing research work on these 2 tasks. And so the idea is, now that we have BabelNet as a huge multilingual inventory for both encyclopedic and lexicographic knowledge, why don't we perform the 2 tasks together in any language? And so this motivates the acronym, because the idea is that you have a Jedi, which is Yoda, a Jedi in each country. Sorry, Netherlands is not there. There are many countries which there's no space. I would have liked to have a Jedi for each language, but I selected just some of them. And the idea is that each of them carries not a laser's word, but a laser flag. And so all the knowledge that comes from their country, and we use all this knowledge together to disambiguate in a given language. So that's the idea. And so this gives us the multi-Jedi acronym meaning. So what? Babelfy. So Babelfy is this system that performs multilingual word sense disambiguation and entity linking jointly. And so we have a sentence. We consider all the possible meanings of the words in context. And if we have mentions like Thomas, we consider all the various terms which named entities which contain as substring the mention. For example, Thomas, we have set Thomas, Thomas Müller, Thomas a novel, but you have thousands of Thomas in BabelNet. And Mario, you have a lot of Marios. You have Mario as the character, Mario Gomez, and so on. And so we have a lot of ambiguity. This is an issue, of course. And in order to address this ambiguity, what we do is to create an interpretation graph. So basically, for all the possible interpretations of the various mentions and words in context, we create a node in this graph and connect pairs of nodes if there is a semantic relatedness relation between the two, let's say in BabelNet. And then you can see that there are various interpretations with different connections. The idea is to identify that subgraph which has the highest degree of connectivity. And so you want to identify the densest subgraph here, and as a result, if possible, discard those meanings which are peripheral, those interpretations which are peripheral in the graph, like Mario Adorf and Thomas Millian, who's a B-movie actor, was a B-movie actor in Italy, Mario Basler. So you discard peripheral interpretations, and as a result, you get a graph of more higher confidence interpretations, but you still have some ambiguity, so you use connectivity measures to determine what are the strongest interpretations. As a result of this, you get rid of all this ambiguity, and hopefully you identify the right meanings for these words or mentions in context. This is an excerpt of the real graph in BabelNet. So, and these are the interpretations that were chosen, but there are many other possible interpretations, but you see that they are more peripheral, more disconnected, and so on. We performed experiments. Of course, this system is not perfect, because disambiguation is a very difficult problem, but in all the experiments, we can see that either we are in the same ballpark or as state-of-the-art supervised systems, which are trained with thousands and thousands of examples, while Babelfy is not trained. So Babelfy, on all these sense-eval, SEM-eval disambiguation tasks, also in multiple languages, is either in the same ballpark or performs at the state-of-the-art. And also on entity linking, it obtains state-of-the-art performance. So this is better than any other system, and in the Cornell AIDA dataset, it gets similar performance as the state-of-the-art. So it's really doing well. So now let's ask ourselves the question, does it understand the mouse ate the cheese? So luckily it does. So at least it makes me happy, okay? Because you get this, and now I think it's very nice, because if I don't speak English, I can at least understand what we're talking about. So we're talking, well, obviously eating is general eating sense, so there's a young girl, but the point is that you understand the meaning of the verb, and so you get the meaning. And now the other thing is, why are we performing word sense disambiguation and entity linking together? And I can show you two examples. I was so lucky I could drive a Ferrari Testarossa, and drive and Ferrari Testarossa help each other because Ferrari Testarossa is unambiguous, but drive is very ambiguous. And so the sense of drive is selected thanks to Ferrari Testarossa being there. Or vice versa. We wrote PageRank in Java. Java is ambiguous because there's the island, there's a coffee, there's the Java programming language. But thanks to writing the computer science meaning and PageRank, which is a computer science term, you can choose the right meaning for Java, which is a named entity. So now, what can we do with Babelfy? You can disambiguate text written in any language. For example, well, I tried Italian. This is a headline about Twitter improving their private chat. You can communicate with everybody. Twitter potenzia chat privata, si può comunicare con tutti. And the nice thing is that you get these pictures like communicate, even verbs have pictures, chat, and so on. And so this gives us really the gist of what we're talking about. Now, yesterday I went to BBC News and I wanted to see how it would perform on a real news text. So I'm going to do it here. Sorry, can't find the pointer. Okay. So let me copy and paste some of this text. So there's a China blasts port city rocked by explosions. It's not a nice news, but let's take all this, okay? And then let's copy and paste into Babelfy. English. So what we get is, well, unfortunately I get the definitions in Italian because I'm working with an Italian browser, but if you're working with an English browser, you get the definitions in English. So you have, I don't know, massive explosion, northern city, Tianjin, living, dead, hundreds, state media, state, injured, cause physical damage. So you have a lot of information, warehouse storing, warehouse, and so on. So I think it's, I mean, especially with news where there is a lot of information here, you get very interesting output. So, and it works pretty well. Obviously, there are some mistakes. Like area, for example, here is wrong because this is a geometrical meaning. But there's a lot which is correct. So, okay, now I'll go back to the presentation. So this is to show that if you take a news in any language, it can be, well, I tried English, but I'm going to try a more compelling example. So the other interesting thing is that you can disambiguate in a language agnostic setting. What does it mean? Well, it means that even if you don't know the language, or you mix text in different languages, you can just input it to Babelfy because there's a setting in which it just doesn't try to use a given language, the information in a given language. It uses all the lexicalizations in all the languages in BabelNet. For example, this technology, Samsung S5 fingerprint flow exposed, problema impronte, sblocco telefono, Galaxy S5. You say agnostic here, you select agnostic, and you get this disambiguation, which is, in this example, perfect. Like flow, you have problema, impronte is the same as fingerprint. But now, to do something more challenging, I wanted to try the crazy polyglot. So a guy who apparently speaks a lot of languages. I mean, at least he claims so. So I took the first paragraph of the eLex 2015 page and translated it. I know French and a bit of Spanish, so I translated it into these languages, hopefully. So into plus Chinese. So in today's knowledge and information society, le paysage lexicographique est plus hétérogène que jamais. Possono le risorse standalone competere con múltiples funciones portales lexicográficas multilingüe y servicios web, niao, xie, pinchelin, which are the only 3 words in Chinese that I know for surviving, which are hello, thanks, and ice cream. Pinchelin. Okay, so you take all of this and input it to, sorry, I'll do it from here because I'm doing it live, okay? So I'm copying and paste this text. Okay. Okay. I have to remove the language labels. Okay, then agnostic here. And we see what comes out. So knowledge, we have information society, which is perfect. Paysage, it's an expanse of scenery that can be single view, maybe it's pretty okay. Lexicographique, hétérogène, jamais, in nessun momento, it's fine. Resource is fine. Available source of wealth. No, because here we're talking about machine-readable resources, but obviously this is very specific. Funciones, portale web, multilingue, servicios web, this is a web service, I think, in informatica and web service, yeah. Well, and then probably this is a bit more, I don't understand this, because telecommunications, anyone speaking Chinese? But at least you get some ideas, okay? Telecommunications, a user is a person, you will have a user here. Okay, so anyway, it's working pretty well. I mean, I just mixed language, okay? So it's something that you couldn't do with any other system. So I'm really proud of this, honestly. Sorry, I missed where, okay, I'm here. Okay, the crazy polyglot successful. So now, let's talk a little bit about the linguistic linked open data cloud. So as I said, BabelNet is starting to be more and more central in this cloud of linked data resources. Now, if we have another resource, like Yate or any other resource, that is not linked to a big resource here, what could we do? I mean, what can I do with my linguistic, maybe domain-oriented resource? So you have this resource, and you would like to connect it to the linguistic linked open data cloud. So what should you do? I mean, you should apply some algorithm. You cannot do it manually, because you don't want to spend all that money. Maybe you want to semi-automatically do it. So like, for example, doing it with an algorithm and then validate the result, which is much faster. But it's not easy. How to do that? Well, you could apply Babelfy. And that's what we are doing with Yate. So it's a case study for us. It's the EU's institutional terminology database containing 1.4 million multilingual entries. You see that there's a lot of domain information, domain terms, like lettuce, lettuce mosaic, lettuce harvester, and so on. So there's a lot of very domain specific. There's also a lot of noise, unfortunately, but this is another issue that can also be addressed, but we're not addressing at the moment. So you have all this information. Let's say you have lettuce harvester, and you see that you have also a lot of multilinguality here, because you have many lexicalizations in different languages, like raccoglitrice di lattuga, raccolteuse del laitue, and so on. So the goal is to automatically and semantically link Yate, each entry in Yate, to BabelNet using a language and resource agnostic approach. And so we want to link the two resources. And what are the cases? There are three cases. One in which the term is available, is monosemous. The term is monosemous, so tomato juice is not ambiguous, neither in Yate nor in BabelNet. And so it's very easy to perform the linking and then validate it. So this is obvious, and as a result you get the additional information from BabelNet, the pictures, multiple definitions, multiple examples, and so on. Then there are more complex examples, like how to link tomato to BabelNet. Tomato is ambiguous. For example, the tomato fruit entry in Yate, there are multiple entries because it's a bit noisy, but let's say agri-foodstuffs, you have multiple translations in different languages. This is, yeah. But in BabelNet, it's ambiguous in Yate, but it's even more ambiguous in BabelNet because you have tomato as a shade of orange, you have tomato in the fruit sense, you have tomato firmware, you have a musician called Tomato, and you want to choose the right meaning. And so how to do that? Well, an idea is to apply Babelfy in the agnostic setting to the entire lexical content from the Yate entry. So you take all the lexicalizations in the different languages, you take the definitions available in Yate, you take the references, all the lexical context that you can use, and apply agnostic disambiguation and obtain the result. And as a result, you get, you get meanings associated with each of the entries. And if tomato is available in different languages, most likely it's going to be used in the, with translations in the right meaning. And so if you take the majority sense for tomato associated across languages, you're going to find out that the fruit sense is the one you want to link the entry to. Unfortunately, there's even a more complex case in which the term is not available in BabelNet. And that is normal because when you deal with very domain-specific resources like IATE, like for example, pomodoro di serra, tomate de serre, greenhouse tomatoes, or maybe tomato grown under glass, I don't know if it's correct in English. This is not available in BabelNet. It's very specific. So what can you do? You have also additional context here, but what can you do? Well, you can still link to BabelNet. You can link to the most semantically relevant concepts like tomato, like greenhouse, or glass. So you can link to these. How? Well, you take, again, the multilingual context and you disambiguate in an agnostic setting, and you select the most frequent meanings across all the text. And so, for example, you can see that across languages, tomato is recurring. So you might at least be suggested that tomato is to be linked, that pomodoro di serra is to be linked as a related concept to tomato, or as a see also RDF relation, or whatever. And you can also do this with glass or grow as a verb. So it's very interesting because you can identify relations between very domain-specific terms and non-domain and more general knowledge from BabelNet. Actually, there's much, much more. This is LREC last year. And, but there's no time now, so little time. So I'll just give you a preview of two other things we're doing, which are a bit more technical, but I really wanted to talk about these things. But there's no time, so I'll be very, I won't go into details. So one is that there's all this fuss about neural networks and word embeddings. So trying to create latent representations of words, for words. And so as a result of identifying word embeddings, basically for a given word in a given language, you obtain a vector, which is a low-dimensional vector with latent information. And why are you doing this? Because then you can compare these latent vectors with other vectors for other words and see what are the closest words in your lexicon. For example, you want to see whether car and motor car are semantically similar. And so as a result, you train a neural network and you obtain these latent representations and you compare them and see that car and motor car are synonymous. But the problem is that you're doing this with words. What we did was, let's work with senses, because especially with verbs and ambiguous nouns, you cannot just conflate all the meanings into a single representation. You want an individual representation for each and every sense of the given word. And so what we did was to disambiguate the entire English Wikipedia with Babelfy, and then train a CBAO a neural network from Mikolov et al. With a 5-word window. Basically, the network tries to classify, given a context, given a context with a target, with a gap in the middle, it tries to identify the word that would occur in the middle. And once you train this with very large amounts of text, then you get the weights. As a result of the training, you get the weights on this network, and these are your embeddings. And in this case, because we are training the network with senses and not with words, we get sense embeddings. So the vectors, the representations that we get here are for senses and not for words. And so the latent vectors are now sense-specific. So now what you can do is, for the first sense of bank, which is the geographical meaning of bank in BabelNet, you have, I don't know, the closest synsets in BabelNet are upstream, run in the river sense, confluence, river, stream. But for bank in the financial sense, you have commercial bank, trust bank, national bank, banking, financial institution, and so on. And the same for any other polysemous word, like number or hood. You see number phone, you get calls, dial, operator, and acting, and so on. So this is a first result. And we also performed experiments, and these are all the state-of-the-art systems performing semantic similarity using either word embeddings, ambiguous word embeddings, or other approaches, and SenseEmbed obtains state-of-the-art results in many, many different data sets for calculating word similarity. So word similarity, verb similarity, and so on. We also provided a second vector representation for a given scene set, which is this time explicit. So instead of being latent, it's explicit, which means that the vector, you can read the vector. So for a given scene set, for example, for the scene set of fruit, you can read the scene set and the vector, and the vector, each component in the vector has a meaning. And it means that the highest value components are the concepts which are activated by the scene set. For example, for fruit, you will have eat, you will have flesh, you will have juicy. So all these components will be high in value and the others will be low. And this is thanks to a generalization also made available enabled by the Wikipedia by taxonomy I talked about before. And the nice thing is that this vector is multilingual. So now a scene set has a vector representation which is multilingual. So basically I can compare meanings written in different languages, expressed in different languages, by just comparing their corresponding vectors. And the vectors are compatible, even if we are working with different languages. So I can compare these vectors and see what is the similarity between mela and apple, or mela and fruit, and so on. And when we perform experiments, we are close to the state of the art in English on word similarity, and on other languages we are well above the state of the art, German, French, and we also performed other experiments. Finally, I'm going to give you a preview of the next version of BabelNet. The current version is 3.0. 3.5 will be a knowledge base. So now I cannot call BabelNet a knowledge base because it's more of a multilingual, lexicalized semantic network. But it's not really a knowledge base because it doesn't provide relations, domain-specific relations, or named entity-specific relations like, for example, DBpedia does. So you don't have born in, or a child of, or a word received. The thing is that now we are going to, now in August, we are going to finish this work on labeling relations. And basically all those edges, all those relations that you saw in the graph visualization browser, now you can have them also available with labels. And so you know that Steve Jobs was a child of Lisa Jobs, and he received an award, and his occupation was this, and so on. And this will be much bigger than DBpedia, because we are going to extract data from Wikidata, from info boxes, and also from relation extracted with automatic procedures using open information extraction techniques. And we'll also have domain labels, so millions of scene sets annotated with domain labels, like fruit for apple, in the food and drink for the fruit meaning of apple, computing for the Apple Inc. Meaning, music for the Apple album meaning, and phrases and collocations. So for bus, vehicle, driver, stop, station, and these are disambiguated. These are not just words. These are links from a given meaning of bus to a given meaning of driver, stop, station, and so on. Same for bus, computer, and so on, for millions of meanings. So to summarize, I talked about BabelNet, Babelfy, and gave a preview of these two different vector representations based on BabelNet. Sorry. And finally, I gave a preview on BabelNet 3.5, which will be out in September. So now, what will you do with BabelNet tonight? Thank you.
Thank you very much, Roberto. Questions?
Thanks for your talk. Well, since we are here at the lexicography conference, I think I will ask fairly obvious questions. So if we think about knowledge, a lot of knowledge about different languages, at least European, are, let's say, encapsulated in dictionaries. Which means also knowledge that is not, I think, part of BabelNet now, which relates to the history of languages. So if you would think about dictionaries, would you see it, integrating in what you do here? Would you see them as something linked through RDF and to BabelNet, or would you actually include that knowledge in the BabelNet itself? And one related question is, I could notice that BabelNet uses the most open license resources available, like Wikipedia and Wiktionary and so on. So would copyright issue be relevant here?
Okay, so these are two very good questions. So for example, so what I can say is, at the moment, we're already integrating some dictionary-specific information, especially from Wiktionary. Like, for example, you have pronunciations. You could have etymology if available in Wiktionary. You can also have audio pronunciation, for example, here. So obviously, this is not as much as a professional dictionary, because it really depends on the resources we're integrating. But, for example, Wiktionary also provides some etymological information. But of course, I understand, a normal professional dictionary would have much more information, and why not? I mean, if I could work on some of these dictionaries, I would be very happy to do it. So the thing is, for us, converting to RDF, providing BabelNet in RDF format in the linguistic linked open data cloud is a very nice outcome, but it's not, at the moment, the core business, in the sense that BabelNet exists independently of the linguistic linked open data cloud. In fact, this was created, the conversion to RDF was made after 2-3 years after the first version of BabelNet. So it's just, for us, it's just a format, a version online of BabelNet. So at the moment, yes, it's easy to integrate because these are quite open licenses. But if there were additional resources with more restricted licenses, one could still link, but also using some RDF licensing information, or with just making it available from the website or from the API. Limit, constraint, access, depending on whether you can access that part of BabelNet or not. And actually, it's not necessarily the case that you integrate into BabelNet. You can just link to the other resources, but the other resources need to be at least available somewhere in a machine-readable format that can be easily processed. And that's usually the case in most dictionaries. What was the other question?
Copyright.
Copyright, yeah, answered. Yeah. Okay.
What happens when one of your contributory resources changes? So somebody edits a Wikipedia article. Do you automatically detect that?
It's a good question. It's an excellent question. Well, at the moment, we just rerun our BabelNet creation procedure every 6 months. Actually, with the new version, in order to avoid to realign back to the previous version, we are just keeping the knowledge from early 2015 and just updating what we have with the new lexicalizations from the very same resources, but not creating more knowledge. Ideally, what I would like to do by the end of the year or early next year is a live version of BabelNet that updates itself every day, with the little additions from the various resources. That's the ideal case, but it's not the case for the moment.
Thank you for a very fascinating talk. Just one question. Having browsed through most of these free resources, and most of us have, I think there's quite a lot of overlap between them. So when you talked about these thousands of different definitions and images, are these unique numbers, or have you merged? Or
well, I would say that they are quite unique. So I'm not totally sure. I mean, I can tell you that most of the definitions, we should discard definitions which are exactly the same. I cannot swear it, but I would say that most of the definitions are different. Like, let's take just an example in which you have a lot of definitions, like plane, for example. Most of the definitions are different. So I would say that maybe it's not exactly the case that that number of 40 million textual definitions are all different, but well, they are all most of them are different. Like look at these, for example. An aircraft that has a fixed wing, an airplane or an airplane is a powered fixed wing aircraft, powered aircraft capable of light, so a powered heavier than air. So most of them are different. Then, obviously, what can you do with this? I don't know. Just more definitions to better understand. Computationally, you can do a lot, because this helps a lot. But for a human, it's just more additional definitions. But yeah, I would say that most of them are different, but I didn't calculate, I didn't double check. I'm quite sure we discarded, but should double check, yeah.
Thank you very much for your talk and the nice pictures too. I wanted to ask you, I'm not from this area, but would it work for end users to edit the result of BabelNet directly?
Yeah.
And how would that feed back into the rest?
That's a very good question. We are working on a social version of BabelNet, in which, so basically to improve this website, not only to add editing facilities, because obviously that would be like Wikipedia and maybe not many people would contribute because BabelNet at the moment doesn't have the same visibility as Wikipedia for end users. One thing, in order to motivate users and maybe gamify the thing, the idea is to have to engage the user and allow the user to validate, not only to edit, but also to validate someone else's edits and get credit for that. And so, especially, I think the most interesting thing will be that the edits that the user will validate will be close to his or her interests. Because the user will edit some entries. Maybe I'm interested in computer science, so I edit computer science entries. And so the system will just see where these nodes are in the network and provide similar items to be validated. If I'm interested in computer science, it will provide those kinds of items. And if I validate them, I get points. And so I'm encouraged to do this. And so it will be hopefully a mutually beneficial process. I don't know when we're going to release this, but hopefully next year or end of this year. I think next year. And I hope it will work, that people will annotate, yeah.
Okay, so.
My question goes towards the lower density languages. So I would assume that most of the knowledge in BabelNet actually covers the first N languages. Do you have any solutions for that?
Okay, so I can show you two things. One is the stats. So if you go to stats here, you can see that so the coverage for each language. So these are the number of lemmas by language, number of synsets and so on. You can see that if I go beyond the top 10, you still have, oh, sorry, I have to go down here. You still have millions of entries, well, hundreds of thousands of entries for many, many languages. Obviously, most of these will be named entities because maybe they come from Wikipedia or they come also from Wiktionary, but I don't mean this is all covered, absolutely. I mean, there's a lot, okay? When I go down, I'm still in the tens of thousands, and so, I mean, it's interesting. Of course, when you go down, you have thousands, okay? You don't have much here, you see? So a possible solution to this is gamification. So one thing we are doing is to create video games with a purpose. So video games that people can, sorry, just give me a second. For example, yeah, this is a video game that we developed, but we are doing better games, like a zombie survival game, in which basically the world has been conquered by zombies, and unfortunately some humans have been also infected and some are just zombies, and so you have to play to kill the zombies, but also kill the humans who are infected. How do you identify the infection? Because you shout a password, a word, let's say in English, and they shout another word. If they shout a related word or a good translation in your language, then you don't kill him or her. If they shout random words, they are infected, and so you kill them, okay? So that's an idea, but there are many other ideas of this kind. We also developed an RPG game in which you go around and kill the enemies, and then there are reward chests, and you select, from the reward chests, you select pictures that are relevant for the level concept, and discard those which are irrelevant for the level, for the concept of the level. So you're given a concept at the beginning of each tower, and you have to collect only the pictures which are related to the concept. So there are many things that you can do for this, but we're still working on this. There are many ideas here. Real video games, not just games with a purpose. Games with a purpose are good if they are well designed, but also video games, because a lot of young people are happier to play with these things than to annotate with a normal interface. So that's the hope, that we can engage also people from low-resource languages.
Next question. I was wondering about the PageRank you introduced to identify closed concepts for a given concept, and does corpus frequency of a certain term enter as a relevant factor? I mean, there's, for example, difference if some concept occurs rarely in underlying corpora if you use corpora, or if it is a frequently used concept.
No, here we don't use corpora. We just use the network structure.
Yes, no, I understand, but would you think that this might have a positive impact?
I think so.
Okay.
In fact, the two vector representations I talked about at the end of the presentation are in this direction, because they exploit frequency of senses, not only words, within large texts. So I think there's still a lot of work to be done, but the two things can come together, yes.
Okay, thank you.
Okay. Last question here.
A very short question. Is there any treatment of morphology in morphologically rich languages like Slavic languages?
Okay, so this is also interesting. What we are doing is, we're not showing any morphological information here. We are retrieving all the morphological information from Wiktionary. So in those cases in which the rules are encoded in Wiktionary, like those morphological tables, inflections of verbs for many languages which are available in Wiktionary, we are collecting them and integrating them into Babelfy, for example, because otherwise how do you, we don't have a part-of-speech tagger for all the possible languages. So how do we process text for languages which are morphologically rich? And so what we do is to collect these morphological tables by extracting the rules from Wiktionary and re-implementing them, and having this for some 20, 30 languages at the moment. For the rest, I don't know, because we don't know all these languages. So unless they are available in Wiktionary or someone provides them, I don't know how to cope with this problem. But if you have solutions, I'm happy